Hello, my name is Yeyul. Let me walk you through the lab 2, exercise 1 and 2 briefly. So, let me run the code first. Then the result that comes out here. Uh, in this assignment, I implemented the logistic regression models using scikit-learn to predict the secondary school student performance, whether the student passes or fail based on their final grade G3. First, let me to bring all the libraries here and the data. Start like the loading the data set here using the pandas. This dataset contains various features, but as instructed, I only picked these features only. Next is to convert G3 to the binary target. The this transform the problem into the binary classification task, which is suitable for logistic regression. Next is the data is split into the training dataset and test dataset using an 80-20 ratio. The next is using the scaling. Like since the logistic regression is sensitive to feature magnitude, I applied the standard scaling to all the feature. And now it's time to the model training. The logistic regression models is trained by using the scaled training data. The maximum data is 1,000 to ensure convergence during the optimization. Logistic regression was chosen because it's interpretable and efficient and suitable for binary outcome. So this code is to see the prediction of the model. And the last part, this one is compare the actual digit, the number, like the result with the its model's prediction. So the model achieved the accuracy of the approximately 0.7 for almost 7. This is for the assignment and lab 2 exercise 1. Let me move to the exercise 2. Let me run all the code first. For this assignment, it is for the classifying the mnist digits using support vector machine with the Python. And I used TensorFlow only to batch the dataset, and all model training and prediction and evaluations are done using scikit-learn as required. First, I imported all the libraries here, and TensorFlow is used to fetch the mnist dataset. And then I imported this SVC from scikit-learn to create a support vector machine model. And finally imported the accuracy score to evaluate how well the model predicts the digits. So the dataset is loaded using this one. This function actually returned the dataset like X train and Y train for training data and level label, and X test and Y test for testing data and labels. Each are the 28 times 28 a pixel. This label, each label. For the skip-to-learn model, expect the two-dimension array with the shape I reshaped. That's why I reshaped each 28 and 28 images into the one array of 784 pixels. Next is a normalization. I scale the pixel value from the 0 to 255 to 0 to 1 to make the SVM training more efficient and stable. Normalization helps most machine learning models faster. So next I selected the small subset. The assignment asked to train on the top 60 rows of the training set and test on the top of 10 rows of the test set. So I selected the subset accordingly to meet the requirement. And next was creating and training the SVM model here. I created the support vector machines with the linear kernel. The linear kernel is sufficient for a small example because it is easier to compute. Then I trained the model using 60 training images and their labels. Now it's time to prediction. After training, I used SVM to predict the labels of the top 10 test images. The predict function outputs the predicted digits for each test image. Here is the accuracy. Um, I compared the predicted labels with the true labels using accuracy score. With that result, the accuracy comes as a 0.7. Thank you for listening.